Welcome to Day 7 Notes 2.2 Graphs of Functions. Today we're going to focus on domain and range. We'll plot some graphs as well, and we will identify domain and range. So we're going to look at this first example, and we have to graph y is equal to the absolute value of x plus 1, given the domain from -2 is less than or equal to x, which is less than 1. Now, when I'm thinking domain, that's our x values, right? I want to think walls. Since x goes left to right, I'm kind of trapped between these vertical walls here. So what we can do to kind of help ourselves out, now this isn't part of the graph, this is simply just to help us graph within the proper domain, is we can always do like little tiny notes. I'm going to do them in yellow so they're not too bright. I know x needs to go from -2. So, here are my vertical walls. I'm going to be trapped within here. Okay, and +1. Okay, so I know my graph is going to be within these two walls. All right, so now when we're creating our table, though, we'll go back over here. I'm going to include those. All right, now we should recognize this isn't a line. Something funky is happening. We have an absolute value. So what does that look like? Some of you guys might already know, all right? It should be the shape of a V. Some of you guys may not have any idea what I'm talking about, but we will talk more later on of more efficient ways to graph. But in the meantime, what we're going to do here is I'm just going to take these x value endpoints, all right? And I will start with -2. And I will keep adding values of x until I get to 1. So we go -2, -1, 0, and 1. Okay? We can also make some notes here. At -2, I have a less than or equal to. So that means we're going to have a closed circle. X can actually equal -2. Okay? But at x equals 1, we just have a less than. So that means when x does equal 1, we have to have an open circle because it doesn't actually equal 1 there. It is not including 1. It is everything up into 1. Okay? All right, so now let's go ahead and plug in for our y values. So when x is -2, -2 plus 1 is -1, but when we take the absolute value of that, we get +1. When x is -1, -1 plus 1 is 0, absolute value of 0 is still 0. And when x is 1, we should get the absolute value of 1, or sorry, when x is 0, we get the absolute value of 1, which is 1. And when x is 1, we get 2 for y. Okay, so now we can go ahead and plug these in and graph it, and then we'll identify our range from there. So when I am plotting -2, 1, I know I am going to have a closed circle there. Okay, so we have a closed circle at -2, 1, and then I go -1, 0, I go 0, 1, and then along this next wall, I have 1, 2, but I have an open circle there. So now we can go ahead and connect, and we see we have this V shape. Okay, I've got an open circle on my right wall because our domain does not include 1, but on my left wall, I have a closed circle. You don't need to have these yellow boundaries, but sometimes it helps just for visualization. All right, so now we need to talk about our range. So our range, I think about as floor and ceiling, okay? So we can do the same kind of thing over on our graph, as I can draw a floor that touches my graph, or that my graph touches, right? All right, and then I can draw a ceiling that kind of caps off my graph. So my graph is between this floor and ceiling. Okay, so these represent our y values in terms of our range. So what's the smallest y value we have? Well, we should recognize that the smallest y value is 0. So we know our range is going to go from 0, and we're going to compare that to y, and the highest y value is along this horizontal line, which is 2. Now we just need to fill in the proper inequalities, all right? So, does our graph touch this line, and can y equal 0? The answer is yes, so we have a less than or equal to. But when y equals 2 up here, we have that open circle. So this next inequality has to be strictly less than 2. So our range goes from 0 is less than or equal to y, which is less than 2. Okay, now we want to determine the domain and range given this particular graph. So we can do the same thing. We can draw in our vertical walls to help us with the domain, and we can draw in our floor and ceiling to help us with our range. Okay. So our graph is, in fact, sandwiched between these two vertical walls, all right? Now, what are those x values? Well, here we get x equals -4, and here we get x equals 3. Okay, so I know my domain is going to go from -4 to 3, but now we need to figure out the inequality symbols in between. So what we should notice is at this point here on this wall, we have an open circle. So what does that tell us? It tells us that this is going to be strictly less than. -4 is less than x. But then on the right wall, we have a closed circle. So it does in fact touch this vertical wall, and it can equal that x value. So we have x is less than or equal to 3. Okay, so now we have to draw in our walls. Our floor and our ceiling. So what is the lowest y value? Well, we can go ahead and draw that in. And what's our ceiling? What's our highest y value? We're up here. So we can see here, our highest y value is 4, y equals 4, and our lowest is y equals -4. Okay? So now I know my y values are going to go from -4 to +4, and y is going to be in between. And now we just have to ask ourselves, is it less than or equal to? So what again, we should notice we have an open circle when y equals -4. So that's going to be -4 is strictly less than y. But then what's happening at our highest y value? It is touching that line. We can go ahead and say that it's less than or equal to 4. Try this next one on your own. Go ahead and pause the video. Tell me the domain and range, and we'll come back and check each other in just a little bit. Did you get what I got? If you see, I've got my vertical walls at x equals -3 and x equals 2. And so my domain is going to be -3 is less than or equal to x because we have a closed circle there, but less than 2 because we have an open circle at that point in the graph. Our range is going to be inclusive for both of those inequalities. Our lowest, our floor here is y equals -2. Our ceiling is y equals 3, and they equal both of those guys. These last two examples now give you the domain, and you have to graph a possible sketch. That doesn't mean everybody is going to graph the same exact sketch every single time. We can be a little creative if we want, but let's go ahead and give it a try. Okay, so we again can think of it as our domain is those vertical walls, and our range is that floor and the ceiling. So if we go ahead and kind of dash these in, they're not part of the graph, they're just there to help us visualize. We know we are going from -2 for x, so we can go ahead and draw in those boundaries, and we're going all the way up to +1. Okay, so I know my graph is going to be contained within those two walls, and our range goes from y equals -3, so we're down here, to y equals +3, so we're up here. Okay, so now we get to be creative, and we know that we are stuck within these. Now, another thing we might want to note is that along these walls, this left wall here, which goes along with this point, since it's less than or equal to, I know I have a closed circle here. So maybe I just put C for closed, and I will also have a closed circle at x equals 1, okay? Now, what's going to happen when y equals -3? Well, according to this, we also have less than or equal to, so we know we need a closed circle there, and we will need a closed circle on y equals +3. Now, we could also be more creative, but let's see what we've got, okay? So the very least creative we could be is a line, okay? So it's a line. I could start in this corner with a closed circle, right? It meets both of those, and I could end in that following corner. And there, my requirement is met. My domain goes from -2 to +1, and my range goes from -3 to +3. Now, this isn't very creative, so do you want to see if you can be a little bit more creative that still matches the domain and range? Okay, so maybe I start in the same place as we did here, closed circle, but this time I'm not going to go up to that far right corner. I'm going to hit this ceiling, and then I'm going to come back down, and maybe I end up over here. Do I still meet my requirements? Does my domain still go from -2 to +1? Yep, I'm still within those 2 vertical walls. And does my range go from -3 to +3? Am I still contained and hitting those pieces? The answer is yes, only this time I'm just touching that ceiling and I come back down. Okay, I want you to give this last one a try on your own. So again, pause the video right now, go through, draw a graph or sketch a graph whose domain is 0 less than x, which is less than 3, and whose range goes from 1 less than y less than or equal to 4. Pause and come back. I came up with something that looks like this, okay? And what I kind of look at is I say, all right, my walls and my left vertical wall and my floor here, when they meet, they both need open circles. So that's a good place to start. I can start with an open circle there, and that will suffice with my 0 is less than x and 1 is less than y. But I notice up here at this corner, I need an open circle along this wall, but I need a closed circle along this ceiling. So I can't put a point here. I have to be a little bit more creative. So I just scooted it over a little bit where I touched that ceiling, and then I ended back over here. You didn't necessarily need to end in this corner. You just needed an open circle somewhere along this vertical line. So you might have something different, and if you're questioning whether yours is right, feel free to bring that question to class next time we see you. Have a good day.